things in a reactive way with the help of RabbitMQ. Briefly about myself, the co-founder and CTO, started actually as a designer, and I'm part of Skype Mafia as well, so many of you might know me from there. Reactive architectures. So what does this actually mean? I think the term kind of kicked off when the Reactive Manifesto was produced, but it was floating around back then previously, of course, as well. This was published in September 2014. What does this actually mean? Or actually, let's back off for a second. The manifesto itself, as a term, many of you might know the Agile Manifesto, of course. One of the persons who wrote the Agile Manifesto actually tweeted in 2014 that the Agile is dead because everybody's Agile and like everything's Agile. Like the point of manifesto is to move forward and to kind of make a statement and then build upon that. So I think manifestos are good when they're building blocks. They add rather than compete or subtract, and they kind of add to the growing wisdom. So I think in a sense the Agile Manifesto is kind of like a first brick, and then the Reactive Manifesto is kind of the next brick on the wall. So what does this actually say, this manifesto? It's an initiative of tech-agnostic shared vocabulary of different patterns in architecture, of how to build systems in a way that they are reactive. It states that systems should be reactive to events, load, failure, and users. In other words, they should tolerate any kind of event, any kind of load, any kind of failure, and any kind of amount of users. The goal is to be responsive to what the user wants to do in a timely manner. And the principles how to achieve that are resiliency and elasticity. Reacting to failures and reacting to load. And the bottom of it all is that the architecture is message driven. The components talk with each other using messages. So I'm mostly going to talk about the message-driven part, but as you will see, RabbitMQ and as well as other message queues, actually, they kind of tap into the other parts of the system as well. So you can build upon that and kind of capture some of it from this pyramid here. So systems that are built reactive are flexible, loosely coupled, scalable, more kind of agile, to say, which actually makes them easier to develop, and they are easier to be changed as well over time. They tolerate more failure, and even if it does happen, then it meets it with elegance rather than like disaster. Reactive systems are highly responsive because they can give the user feedback of what goes on. If something takes more time, they will tell that, hey, it's going to take more time. If it can respond quickly, it can respond really quickly because it doesn't have to wait for everything to happen as the user is waiting. So how do queues actually fit into the picture here? So there's like this nice list of using message queues. Like there's 10 big benefits of using message queues. I actually took it from a website which is listed below there. But they kind of talk about the same principles. Many of them are kind of like familiar terms from the previous slides. So just going to walk them through quickly to get a sense of what they actually mean. So decoupling. So you don't need actually to know all the different use cases your system will eventually have one day as you start your project. Like you can just start sending messages which are implicit and data-based. You can always extend and add processes later on. You can mix and swap them. But the decoupling part is that you can produce messages in one place and consume them in a different place. There's no coupling between them. And I'm going to talk about that in more detail later as well. So next up, redundancy. Sometimes, as we all know, services die when they process data. Unless the data is persisted immediately, it gets lost. But message queues actually help to mitigate that problem because eventually you can write things off and no job gets lost, because even if the consumer isn't there or dies, then you can still list up the jobs that need to be done. Load balancing, scalability. So message queues enable really simple scaling. You can just add instances basically, because eventually they will tap into the same message queue and start consuming with the other consumers. So load balancing really is part of the game as well, because there's no code changes needed, there's no configuration needed. You can just basically add instances. Elasticity and spikeability, talk about that once more. So once you hit Hacker News front page, you're going to see lots of traffic. The user expects the functioning app still there, be there, but if the traffic goes beyond like normal, then it's basically often the case that it just dies, right? But at the same time, it's really wasteful to have all the resources there and be like kind of fully provisioned at all times. Maybe I'm going to be in a Hacker News one day, or maybe I'm going to be in the front page of some big news site or whatever. So queues actually help that a lot, and you can do auto scaling based on the queue length or the consumer utilization of the queue, which will be like a second step, because even before that you can still process all the things just in a timely manner. And do some things later, basically. So you don't need to do everything at once, which the queue will help you do later. Resiliency. So when part of your architecture fails, then the other part doesn't fail, right? That's always the case. It doesn't take down the entire system. That's like, I put the smiley face there because that is true, right? Everyone knows that it's always the case. But anyway, if the service that is processing messages fails, you can still, as I said before as well, you can still push new messages in the system, and they will eventually be consumed later on. And there's an example here of a frustrated customer. So when the customer does something and your system fails somewhere in the middle, then that job will eventually be still done, and that's a way to avoid a frustrated customer. Just again, it's highly maybe like theoretical, but I'm going to have some more precise examples later on as well. Delivery guarantees. So message queues actually will give you the guarantee that the messages will eventually be processed, and you can have some more guarantees built into the system if you'd like to, and the messages will eventually be processed at least once. That means that if you have to do retries, then you can do retries, but that will be at least once processed. Right, and the way it works actually is that most often the case, and specifically with RabbitMQ as well, that if you have messages in the queue, then if you start consuming them, they will be reserved, those specific messages that are being actually delivered or processed. And only if the consumer tells that, hey, I'm finished, I'm done with this is successfully done, then the message queue will discard that message and then give you the next one. So this is the way to kind of build the delivery guarantee in that, so you will know that this message actually got consumed properly and acted upon properly.
Question, please.
Yeah.
So does it mean that this transaction responsibility needs to be implemented inside a service that consumes the message? Like so. Yeah,
there's two approaches there, two parts of it actually. So maybe many of you are familiar with transaction as such, like in the database world, right? So in message queues, it's twofold. So there's one aspect of pushing the message, which is the publishing part, and the other part is consuming the message. I will come back to that in the next slide as well. It's not as simple as just, yes, it will be guaranteed. It will be guaranteed if you want to, but there's two aspects you need to take into account when publishing and when consuming. Ordering guarantees. So message queues will eventually be ordered, and it's served on the basis of first in, first out, FIFO. But there's a note to be taken on having multiple consumers on a single queue. So yes, the order is guaranteed, but the order of consumption is guaranteed. So you might be having one consumer being lower than the other, which means that one message will be parsed or processed faster, and thus guarantee isn't actually there. But if you really want to have ordering guarantee, you can have it by having a single worker and only take one message at a time. Then it will be guaranteed. The other part of ordering guarantee is, of course, that if you have lots of messages flowing in at a really high throughput, you can't really make a difference whether one happened first or the other. Like there's like 1,000 messages a second. Like there's two events that might have happened at the same millisecond. So theoretically it's there, but in practice there's many small aspects to be aware of. All right, buffering. So you might just want to actually pile up a buffer and then process them at once. That's one option. You can do that using message queues. Otherwise, it would be really difficult for you to kind of buffer them into some other place. Message queues are a really good example of that. Also, different tasks take different amount of time. So you might have an image upload and then applying a filter to it. It's just basically different tasks take different time, and you can actually utilize that each worker will have their own queue and they will be worked in parallel. So data flow visibility, that's one of the biggest upsides of having a message queue system, and especially RabbitMQ has a really good interface. I will show it in a second. So it will give you a visibility into how much data is flowing from which place to which place across your system. And it's not an easy task if you have a distributed system of lots of services. This is an example of RabbitMQ. I will come back to the UI later as well, but what you can see here is the message rates, and these are queues, by the way. So you can see how many messages are being delivered to that queue, and how fast are they acknowledged, and whether there's a pile-up of messages or not. So this is a really good overview of what goes on in your system, basically. Right, so async communication. It's just like a broad term, but you might just not want to deal with everything at once. You might want to write things down and do them later. You might want to retry later. If a network request is in the question, then maybe there's another service which isn't available right now. You can keep the thing in the queue and then retry later. That's also possible with message queues. Right, so those are the main 10 benefits. So RabbitMQ. It's an AMQP message broker written in Erlang, launched in 2007, written in London, but then got acquired, and now it's part of Pivotal. And it's they're a core participant in the AMQP working group. So what is this AMQP thing? This is Advanced Message Queue Protocol. It's an open standard. It's nothing to do with Rabbit as such, but they kind of founded it partly. In theory, it's provider agnostic, so you would be able to swap RabbitMQ with a different AMQP server, but I don't recommend doing that. It's not a good thing to do, probably. It has client libraries in all major programming languages. The most recent specification of this protocol is 1.0. However, RabbitMQ uses 0.9.1 as of today still. They are having the 1.0 interface in beta right now. It has a face, so you can actually log into it. It doesn't only provide you some cryptic console interface. It actually has a UI. There's a nice graphing tools in it, so you can see what goes on in the bonnet, basically. All right, so the basic concept of RabbitMQ, and in theory, as I said, you can swap the RabbitMQ with any AMQP server as such, is that you have a publisher, which is your service that publishes your events. They go into RabbitMQ server and they land in a thing called Exchange. Exchange is like an inbound pipe to the server, basically, as such. So from Exchange, messages go to queues, and they go there using bindings. And they end up in consumer apps. So these are apps, again, like services. They can end up in a single consumer, or they can end up in multiple consumers from a single queue. That's a really basic concept. There's a specific example here as well. So imagine there's a deal service that says to RabbitMQ about a new deals being added to the system. And so one of the bindings can be that I want to get all the new deals into the statistics queue, and it will be there, basically delivered for you. And the other binding is only asking for specific company's deals. So only company 15 deals will be added to the webhook queue here. So the bindings are kind of like a really important piece of the picture. It's not just arrows, but you can actually route things using bindings from exchanges to queues. So let's walk through the picture in more detail. So publishing, a few things about publishing. So you publish messages. Each message has a routing key, like a subject as such. It has a delivery mode, persistent or not persistent. So this is the part of the question that was asked, like how to actually guarantee the delivery. You should use persistent mode when publishing. That's one part of the story. There's headers. Each message has a header, like content type, application JSON, and the payload, which is the JSON basically. It also has properties, things like correlation ID and app ID, which help you actually to pass through different arguments across your system and use them in later analysis. This is the same thing with a really simple example done in the RabbitMQ admin panel. So you can actually use that to publish messages as well. Otherwise, you would normally do it in an application, really. So that's publishing. Things come into exchanges. So exchange is an AMQP entity in which the messages are received in, or actually sent to, rather. And they on themselves are useless until they're bound to something, bound to a queue, basically. So there's 4 types of exchanges. There's direct, fan-out, topic, headers. I mean, you can pretty much forget about that. The main point is that the type defines what kind of bindings it can have. So the most useful one, I would say, is topic, because it allows regular expression-like bindings. Things that I showed earlier as well, like I want everything to be landed here, and I want only company 15 to be landed there. The other types are kind of more simple, except headers, which is even more advanced, but yeah, I think you can look it up from RabbitMQ docs, because it's all written down. Really good examples are there as well. So bindings are rules in which kind of govern how messages are taken from exchange and routed to different queues, and which queues exactly. Each queue and exchange can have multiple bindings, so it's not one-on-one relation. You can have a single exchange and thousands of bindings and thousands of queues, and one queue having thousands of bindings, if you want to. The really brief example here is like if you publish messages using routing keys, which consist of characteristics, color, and kind of animals, and you can send in things like lazy orange rabbit, or like quick brown fox, which is the classic example. Then the binding example taken from RabbitMQ documentation actually is really simple. Like there's 2 queues here, 2 red queues, and first one will receive all animals that are orange, and the second queue will receive all rabbits and all lazy animals. So this is the topic type exchange, which receives messages and then binds them to different queues, and that allows you to think on from here, basically, how this binding can be useful. So next up, the queues are ordered lists of messages to be consumed, first in, first out. They can be durable or transient, which is the other part of being able to deliver the delivery guarantees, basically. So you need to publish a persistent message to a durable queue. Otherwise, it might get lost, or it's only written to memory, and then it might get still lost along the way. It's basically not normal that things get lost, but if something crashes, then it can happen. I will walk through one of the scenarios later on as well, which might happen. And also, queues can have properties such that it can control the DTL of messages in it. It can have auto expiry, so that the queue actually itself can kind of disappear if you would like to. You can define maximum length of the queue and also the length in bytes. So if you want to kind of restrict your queue somehow, then you can do that. And you can also, and this is rather important, that you actually can have a thing called dead letter handling, which is basically if messages don't end up being consumed in timely manner, or otherwise expire the detail or whatever, you can actually have handling in place that automatically puts them into some other queue or does some other things with that. So that's just a useful tool for doing things like retry later, for example. So consuming. Consuming is the act of receiving and acting upon messages from a queue. It can happen one at a time if you want to, but you can do things like multiple in flight with hacking, which basically means that you can define that I would like to get 10 messages at a time. You will get 10 messages at a time, and if you start acknowledging them, meaning that you will tell the server, hey, I've done everything needed with this message, consider this to be processed, then you will immediately get another one. So there's 10 at flight all the time, basically. So that's what AMQP allows you to do. You can also build delivery and execution guarantees by doing the hacking properly. And as I said, one queue can have multiple consumers, which opens up load balancing possibilities. But then, as I said, the exact order is actually not guaranteed. And a consumer can ask for exclusivity. So there might be a queue and there might be a consumer which comes and tells, hey, I want to subscribe to this queue. Please give me everything from this queue. But I don't want anyone else to consume this queue. And Rabbit will force anyone other away if they come and try to subscribe to the queue. So yeah, subscription is actually like the term used for consuming or being subscribed to a queue is by means of receiving messages from Rabbit that will be consumed by your service. So this is a sequence diagram as well that I draw. So how does this consumption really work? So first off, RabbitMQ pushes the message to the consumer. Before that, obviously, there's a handshake and authorization and everything. But once you're there, you get the message from RabbitMQ in your service. RabbitMQ will mark the message unhacked, meaning that you're still processing it. It's being done in your service. Then your app will try to do something with the message, and it will tell RabbitMQ, I've done everything, and the message will be delivered, basically. That's indication that you will probably get the next message from RabbitMQ once it arrives there. What happens when there's a failure? So RabbitMQ sends the message to the consumer, writes it unhacked. You attempt to process it, but then you die. Oh my God. And then connection reset comes in. This will tell Rabbit that it's time to put the message back to the queue, actually. And so hopefully you will have resiliency in place that there's another consumer that spins up. And then RabbitMQ will also be connected, and you will receive the same message in the different consumer. Hopefully you can then do your job and then go on with next messages. So this is an example of failover, basically, using queues. So specifically in Node.js, and some of it applies to other languages as well. Basically, you have a persistent TCP connection to the server all the time open. This way, Rabbit will push you the messages. There's no polling, and the connection is multiplexed. We're using channels. In AMQP, basically, you can have a single connection, but you can do all kinds of things in a single connection. Those are called channels. We have done some really advanced high-level testing. There's not much difference if you have a single connection versus thousands of connections and each one having a single channel. Didn't have much effect, but just telling you that it's possible to do both ways. And then in Node specifically, basically what happens is a callback function is executed, and there will be an argument, which is a function which you can call back when you have done your job, which is called hack. And that's pretty much it. So just wanted to come back to the basic example once more. And let's go back to the one that had the service names in it. So I wanted to show you how to actually scale your systems specifically with RabbitMQ. So you will have the deal service, and the deals will come in and they will end up in statistics and webhooks, and everything's fine until you actually decide that, hey, I want to add another service that informs Rabbit about new photos being added to the system. And the photos will then be bound later on to statistics and webhooks, and everything's nice. And then basically you can add one more service, which is, I don't know, an analyzer service, which analyzes your deals. It can read the same exchange where new deals come in, and they will end up in an analyzer queue, and analyzer service will take care of that. Then later on, as time goes by, you might need even to do some resizing. You can read the new photos exchange and bound things to a resizing queue, and then have a photo resizer service in place which takes care of it. So you don't really need to go and change the photo service or deal service, because you can just add things on the left or on the right without actually going and kind of tweaking things in both places. So it's like a series of tubes, really. Some like could call it the post box, post office, and postman all in one. I don't really like that term, but this is actually the official RabbitMQ tutorial, which says that RabbitMQ is a post box, post office, and a postman all in one. And I don't think that's good. I think it's dangerous because it kind of lures you to publishing messages which are meant specifically for one consumer. And I think it's really bad because it increases tight coupling between services. So it's better to do it a different way a bit. So the classic example of orchestration versus choreography, which I kind of already briefly touched previously in some recent slides. So here's a specific example of a different case. So imagine there's a user signing up to your service. You create the account for the user, and then you sign up the user to a newsletter in MailChimp. You send the welcome email, and you actually send the welcome gift, like a physical thing to the user. So, and then you're done, and that's the process, right? So with orchestration, how does this look like? So this is a sign-up service that says to newsletter service, hey, subscribe this new user to that newsletter, please. And send the email and send the package will be told to the delivery service. This is all like normal, but then there's a few problems with that. It's basically explicit with a single recipient in mind. All the messages that are being written are specifically telling what to do. And it makes it really hard to plug in new services which will do different things, as I shown previously. So you can't really shape the system organically or grow it because you have all those specific commands being sent, which is really bad. And also what it might seem like is that you will have expectations of completed commands like, hey, subscribe this user to the newsletter, please, and then you can get the response immediately, where you actually didn't subscribe them yet. It's actually just an asynchronous way of telling that this user needs to be subscribed. It doesn't really go with the message queue logic as such. So choreography is another option, which is a lot better option. I will show how. So this is a sign-up service, and it will send out an event that user had signed up, and then newsletter service will listen to that event, and the email sender will also listen to that event, and delivery service will also listen to that event. So this is RabbitMQ. Signups will all be coming to this exchange, and you can have a queue per each service, and they all will do their job by just listening to the signups. So it's like dancing, like independent actors are dancing, and they're basically listening and seeing what happens around them, instead of one service telling the others what to do. That's another better option. So why it's better? So it's responsive because I mean, by design, message queues themselves, they are not actually having the user to wait for all the actions to complete. And it's more logical to read it by just basically sending out the event that the user signed up, instead of telling one service, the other service, and the third service to do something which is like, it's actually not being done immediately, right? It actually goes to the message queue. It's more resilient because you don't have to write those events specifically for each and every service. Well, you can, but it will kind of not fit in with the picture that well. So if one of the work is not being done somewhere, it will be piled up, and it will be still happening once the service comes back. And you can use that to scale services properly. So yeah, it kind of works and fits in much better with the overall picture. So whenever possible, you should embrace it and use it. It's not possible in all situations, but probably it can be done in like most of the places. Another principle is we kind of ties into that as well, is thumb pipes and smart endpoints. It's a bit different, but this is a classical, like old school programming in a really large system. So there's a bunch of services which are really like doing their job, and then in the middle there's a thing called enterprise service bus, which kind of contains all the logic. And I'm actually not that old to be able to work in those things, because I kind of like think that it's more familiar to a bit older programmers maybe who have done things in a larger scale. But anyway, the point here is that enterprise service bus is a component which routes messages, transforms messages, and does all the business logic basically, and it will tell the services what to do, and services don't know much about what's going on with other things in the system. So the logic is all inside the message bus there, the enterprise service bus. And Sam Newman had a really good term for that. It's magic mystery bus. It's like nobody actually understands what goes on in the belly of this thing. The services don't contain any of this logic. It's all contained in the message bus basically. And that's bad. It's really bad. And I totally agree with that. So what to do with RabbitMQ then? We actually deploy an empty RabbitMQ. You don't bind or queue or create any exchanges. You basically just deploy an empty instance, and you don't make the deployment aware of any of the desired data flows once you start deploying it. And the exchanges and bindings and queues are all actually created by the services, so they will know what to do. So let's break this apart. This is the basic concept, and let's draw some lines here. This is the political map, who owns what in the picture here. And so basically there's three countries here. The Kingdom of Deal Service, that will be owned by Deal Service. And the Statistics Service will own that part of the system, and then the Webhook Service will own that part. So this is basically meaning that RabbitMQ itself is left with nothing but dumb pipes. It will just do the job whatever the services ask them to do. So this is the picture here. The services are smart and the pipes are really dumb. That's the way it should be with RabbitMQ. So what about RabbitMQ in the actual wilderness? We started using it in 2012. It's our main backbone of all the async communication which happens from service to service. All data changes that users make in Pipedrive are actually published to RabbitMQ. So whenever you add a new deal or create a new person or do whatever in the system, basically, they're all sent to RabbitMQ. We are averaging about 1,700 messages per second, sometimes more, approximately 140 million a day. And this is just pulled out this yesterday from our live RabbitMQ, some numbers here of the rates at which messages are being consumed and published. So actually, you can see that publishing is actually a lot smaller than delivery, which is why it's good to know that actually you can publish things into exchanges, but as you have multiple bindings, they will end up as multiple messages in different queues, which means that delivery is much higher. That's might be otherwise a bit misunderstandable in the first place if you start looking at graphs. We actually deployed a 3-node cluster, then scaled it to a 5-node cluster, but then we realized that for us it makes more sense to actually have multiple small clusters. So we started seeing network overhead. We didn't have time to deal with that. There isn't much problem doing a really big cluster. I will give you an example in a few moments as well. But for us, it was much easier to handle traffic in a semi-isolated kind of smaller boxes. So it wasn't an architecture decision. It wasn't a technical constraint. RabbitMQ does scale, and it scales really well. I'm also going to give you 3 things to be mindful of. So first question is, who owns an exchange? As I said previously, the deal service owned its own exchange where it publishes messages to. It should be the one that creates it. But the other parts, which depend on this exchange, because they will have to do bindings from it, and if they can't, they will throw an error. So the question really is that who will actually create the exchange? There should be one owner, otherwise you will have like same structure in 2 different places. We haven't solved it properly yet. We have structures in both places, so when a service wants to write something to RabbitMQ, it will automatically create the exchange with the desired properties. But if a service wants to consume something and it knows that it wants to consume those messages from a queue that is bound to this specific exchange, and if the exchange doesn't exist, you can't really bind anything. So you need to have the structure of the exchange in the other service as well. Maybe there's a way to just die when the exchange doesn't exist. I don't know. That's one question that is kind of, you have to be aware of this aspect when dealing with lots of services and RabbitMQ. The other thing is that adding and removing bindings is like changing database schema. It doesn't come cheap, so it takes time. You don't really want to do it. We used to do it. We used to have a service. I'm going to give you an example. we basically had a service which created a new binding and a new queue per each connected user who logged into Pipedrive. So, but it's not meant for that. It's meant for having a great throughput of messages. It's meant for passing through lots of data really fast. But if you start changing the rules really fast on a really massive scale, it doesn't really perform that well. So be aware of that. So the service which we had this problem in was called Socket Queue. It's basically a piping service between RabbitMQ and the user's browser. It takes data from EMQP and writes it to WebSocket, which is why it's Socket Queue is the name. We created one binding and one queue per each connected user, as I said, and also we had one WebSocket connection open. So there was a one-to-one relation. We took from RabbitMQ, and then whatever was in the queue, we pushed it to WebSocket and marked it as delivered in the RabbitMQ and take the next one and the next one. It was horizontally scalable. We could add just more services, but the problem actually we started seeing is in this part here. That part didn't scale. So I'm going to show what this is about. So as I said, we created a queue per each connected user. Those are users here on the right-hand side. And we had a number of instances. Each instance was responsible for a specific set of users. And for each user, there was a queue in RabbitMQ. We had like 10,000 queues, 10,000 bindings. And all of them were coming from the single exchange, which was receiving about 300 messages per second. So it didn't really scale beyond 10,000 queues anymore. It was just slow. This was the solution. Actually, Eero was working on that. Eero's just sitting here and watching. I don't take any credit of this, and it was a really good fix. We just basically moved the handling of the piping to the service itself. Instead of creating thousands of queues, we just created one per each instance and did all the routing in the service. So the service was a bit thicker, and the previous one was this, and the other one was that. So yeah, so we from the 1.0 architecture, we moved to the 2.0 architecture, which was that we had one queue and one binding per each service instance, and we had one-to-many relation between the queue and the WebSocket connection. So actually, yeah, and we were able to scale it way beyond 20,000. There's right now the simultaneous amount of online users that we are serving. And it hasn't had any problems ever since. The most problematic part was actually the initial setup. So when we upgraded the version of the service or did a restart to the service, then all those queues and bindings needed to happen really fast. When the users were logged in and they wanted to kind of get the new connection and get the new data down really fast. So setting up thousands of queues and bindings really in a short amount of time doesn't work. Don't do that. So delivery guarantees. So as I said, there's two parts of it, but the main point is that a thing called publisher acknowledgement is one that really gives you the guarantee. So you can have a persistent, I will tell you an example as well. So you have a persistent message that is being sent to RabbitMQ. It receives it, but it doesn't write it to disk immediately because it kind of tries to pass it through RAM really fast if possible. It tells you that it received your message. It goes to a durable queue. A consumer picks it up and starts processing. But then server dies. Except when it comes back, the message is gone. It's nowhere, anywhere at all. So publisher acknowledgement is basically a thing which will give you the option to, and you can read about it from their site as well. It's a way to set up the publishing channel in a way that you want to know only when the message is actually written to disk on the server as well. So this is like the final seal on the package, that you send something in, you only want to be aware when it was written down to the disk until you will kind of consider it being done from the sending part. And then the processing part will happen. It will be guaranteed because it's written to disk. So the server might die, it come back online, and the messages will be persisted on the disk. So this is an important notice. So what about RabbitMQ elsewhere? There is this experiment which was done on Google Cloud. They actually sent in 1 million messages per second. They used a combination of 32 RabbitMQ servers all clustered up. And so 1 million messages per second translates to 86 billion basically a day. And just to put this into context, so this is proof here. They have a screenshot as well. They actually did more. They did 1,400,000 something. So to put this into context, 11 billion is the SMS traffic globally per day. In 2016, just a few days ago actually, Apple said that it processes about 17.2 billion iMessages globally. Facebook Messenger, WhatsApp combined is 45 billion, and then the single RabbitMQ experiment is 86 billion. I'd say it's pretty remarkable. Yeah, so that's pretty much it for me. Thank you. And there's a little promo code for anyone who wants to try Pipedrive. And by the way, we're hiring as well. Thank you. Yeah.
Some questions from audience.
Yes.
This was first.
Yeah, okay. So let's say you want to migrate data.
Yeah.
You have live server running with these queues, and then you want to change the JSON, like the format of the message.
Yeah.
You have to change basically the source and all of the recipients, and at the same time, this in-memory state translated into new state. How do you do that?
There's many ways you can do that. Probably you can do versioning inside the payload if you want to. If you really want to do versioning, then you can do that. Have the messages be versioned, and you can handle different versions differently.
So do you create another service as a source and another queue, and then wait until this empties?
There's many ways, yeah. I mean, there's one way of doing that, I would say, is that you can actually use routing keys to differentiate between different versions of messages, if you'd like to do that. Yeah, there's one option. You can bind version 1 to a different set of services, and then version 2 to a different set of services.
So you didn't encounter this problem?
We haven't had this problem, no. We kind of have tried to stick with the format that we kind of have in the first place, and then extend it, add new keys, but don't change existing keys. And if we really want to change the data structure, like ultimately, we can, like internally at least, we have had the chance to coordinate things and change both sides then, but it hasn't been a major problem, no.
But in terms of code, you have to change it in all of these cases, like in all services. Do you manage version control system so that all the services are updated at the same time, or you have multiple versions?
Yes, you can have multiple versions. Yeah, but we haven't had this problem. But I would say it is possible to publish using the version number in the routing key, and then only have the consumer side of it have like multiple versions, the old version running and the new version running, and they can route things accordingly so that the new messages actually go to the new consumer and the old one goes to the old one.
Okay, and the second question is, well, with this distributed system, you have these consumers, but the source doesn't know did they actually do something. So let's say you have a new user and you upload a picture, but you want to make sure that like if he paid or not in the end, you have to construct these queues back so that the source would understand.
You
create like a central service that controls others, or
no. So whenever money is involved, everyone's like really cautious, right? There's two ways, actually more, but RabbitMQ has a built-in mechanism for you can publish message, and then inside the header you can actually specify the exchange from which you would like to get the reply from, or basically a concept of I will tell that, hey, this is the job you need to do, and once anyone does it, let me know using this channel, basically. And that's one option of doing that. The other one is, which we are using, is basically a service which basically pushes this data down to the user a later time. So this is the socket queue service. Basically, you can create the deal, or actually, better example, you can add a person to Pipedrive, and then we add the person immediately and give you the API response But later on, like as soon as possible, of course, we try to look up from different services out there a picture of the person that you added, using the email address or using the name and combination. So that might take more time. Once we get the picture and download it and process it and kind of write it to the person's API, we create an event that the person was updated. And that event will be handled to socket queue and will actually come down to the user's browser by means of server push. So you will get the message that, or like you will actually see the picture popping up. It might take a second or so, but that approach is also possible. You just listen to you listen to messages.
Another question here.
Yeah.
So how many services do you have interconnected through queues, and how do you manage the service network complexity?
Well, really big help, of course, is the RabbitMQ itself, which lists all the connections and queues and the rates of things flowing. But other than that, it's basically just regular architecture planning and kind of agreeing on which things make sense to read from and write to. And how many we have, I haven't counted, but at least 30, I'd say. Yeah.
Questions from here, both registered to.
Yeah. Do you have any experience with Hornet queue? Can you maybe compare Hornet queue and?
No, I haven't heard it, but yeah, no.
It's under Apache, I think.
Yeah, there's a few more which I know, which I haven't tried, but are worth pointing out. There's IronIO, IronMQ actually, IronMQ, and the other one is this Kafka, yeah, Apache Kafka.
A guy with the red shirt.
Yeah.
Was next.
I'm used to thinking about transactions in server.
Yes.
Do I understand it right that in RabbitMQ there is no exception handling or rollback, but the idea is the reliability comes from the fact that the messages will always be processed at some time.
Yes, exactly. So yeah, the kind of the term transaction does exist. It means that the transaction is that I will publish something and I will get the confirmation that it's handled the way it should be handled. Whatever the handling means. Sometimes it means that it will be routed to a queue and will be written to the queue and it's there, and the service will know that it's there and it will be done at some point of time by someone. If there's no queue behind it, it will be basically told you that I've received the message but I don't have any routes, and thus it will not go anywhere. So it's basically kind of transaction. So you can act upon that in the publishing part.
Well, question here.
Two questions. One is like, if you start the like an upload process and then the whole thing triggers other queues and services, how do you debug it so that you see the whole picture of all basically services that were executed because of this?
Yeah. So one word answer is correlation IDs. So each and every request that comes in to your service map from outside will get the correlation ID, and everything that will be logged down somewhere, errors or whatever, will also contain the correlation ID. You can do UID version 4, just random hash basically, and then attach that correlation ID to all the messages that are being written to RabbitMQ. And if you receive something, you use the same correlation ID you received the message with.
But you need to store up all logs.
Yes, well, you have to do logging anyway, yes. And then you can pull up the logs and search the same correlation ID and look where this message this request kind of like touched, which services it touched, in which order, and where the error actually occurred.
And if it's on front end, how do you have like the same like central stuff for front end services? I know you use Backbone or use Backbone. Yeah,
well, that doesn't actually have to do much with the front end, but we do push things down from server using WebSockets, and then the data change event they mostly are kind of just for the user experience. There's nothing meaningful happening after the fact anymore in the front end.
So there is no like central service for front end that updates the views in the same way, pipes down. Right?
Each and every computer, like the end user, would have them locally running on their own machine. So, I mean, we log things down from there as well, but that's not relating to RabbitMQ that much.
Question on first row.
Yeah.
So if you have no queues and then you want to kind of move the architecture of your system to this kind of queues, then like you make a queue and then can you like, let's say you have microservices already, do you start adding queues using the microservices, or do you kind of make a queue and then start attaching stuff to it? Like, it's like, how do you decide
So
what you put a queue between?
the easiest way to migrate when you don't have queues at all is to start publishing something. Then there's something to act upon.
Okay.
So make everyone publish what they do, and then you can build new listeners and attach to the events, basically. That's the easiest way. We started off doing the same thing.
Okay.
Question from Michael Sidorin.
Yeah, my initial question was about how you're debugging situation with messages acknowledged wrongly. As I understood, it's by checking logs, right?
Yes.
And what is your tool to kind of find the thread? How much messages are acknowledged wrongly, and you have to deal with it?
Yeah, to find acknowledged wrongly, I mean, like said that I'm done, but actually it didn't. Yeah, so it's a good question. We use a tool called Graylog. It's kind of okay. I have seen some better tools, but one thing I specifically like about Graylog is that you can search using the properties, like any property, and you can quickly list down and graph things. It's all built into the system, and but yeah, debugging logging basically. And if you don't have logging enough enabled, then we do have a mechanism where we can actually specify that, hey, I want to log everything about this user specifically, and all the services will listen to those, well, not listen to, but will get the information that this user must be logged at any place, and all the things need to be logged down. So once we enable that for the user, we can get more detailed logs only for that specific user. That's built into the logger library that we have shared across the things.
Okay, thank you. Question here.
Yeah. So basically, I had one question. Now I have two.
But you go with one.
Yes, so I can go with two. So you said like you have lots of these microservices or services or however you call it. The question is definitely in logging. So you have kind of ELK stack in order to log everything centralized, or you have to log into all services to see what's going on there, what's going on there. So
yeah,
how you solve? I understand you have enormous amount of log.
Yeah, first of all, we use Graylog. It's comparable to ELK. Mm-hmm. It's all-in-one service that uses Elasticsearch as a backend, but it has a different UI and a different kind of server. ELK is considered the standard, and everyone is using ELK. For some reason, we're using Graylog, and we're quite happy with it right now, for at least so far. So yeah, it's basically a central place. Everyone sends the logs there. It's using a UDP protocol, so the delivery isn't guaranteed as such, but it's fine. We're fine with it.
Okay, and the second one, do you have rule of thumb when you decide that not every problem you can solve with asynchronous way? So you have to be like, there's some APIs and stuff you have to solve synchronous. Yeah. How you decide whenever you do it through RabbitMQ or messaging, or this thing in particular should be done in synchronous way?
Yeah, so I think the first question you want to ask is like, can you do it using message queues? If yes, then do message queues. If you can't, then build an API and have. We are standardizing on like just JSON REST HTTP interface. I mean, and each service can expose HTTP interface as well. If that's the only option on the table, yes.
We can take probably 3 more questions.
Question about message content. Do you have it contain the whole document, basically what happened, or is it references to some actual data in a database or whatever? And how much does message size affect the throughput also?
Yeah, we use the standard way of using it is just put everything in the content. So we have emails flowing through there. You don't have to do that if they have like really big stuff. You can use references, and then what you can do is like if you need to, then you can always ask it from the origin later on. You can do that as well. Depends. The size does have an effect. RabbitMQ is configured so that it can have like a threshold watermark. up until which it can receive messages. If it reaches the watermark, like it is running out of memory or disk, it will actually stop receiving messages. So it will tell the publishers that, hey, I'm full, don't push anything, I'm not taking it anymore. That's the way it handles it. So we have had that problem as well, but it's just a matter of configuration and yeah. So it can have multiple solutions. But we push everything through it, mostly.
Okay, any more questions besides that? Hugo, please.
Question about guaranteed delivery and message acknowledgement. So basically, in case of service has a second data source on database, you need to store data. So does it mean that everywhere, because you mentioned that like you kind of keep taking like your guaranteed delivery for each and every message. So does it mean that everywhere you use two-phase commits and distributed transaction to kind of manage the transaction from MQ and transaction from a database, for example, or you still have some kind of tolerance there?
Yeah, thing with transactions and microservices and fault tolerance is that transaction kind of can be an easy way to do something which can be called a distributed single point of failure.
I understand.
But yeah, I get your question. So it depends on the need specifically, of course. In one place you would like to have it, and you can have it. But yeah, you have to have, like, if you really want to, when you publish, you really want to be sure that it will definitely get done. And you don't care if I mean, it can be asynchronous. Then I'd say, yeah, using all the tricks that I showed, like the persistent delivery and the durable queue, and then the acknowledgement only when it's written to disk, will guarantee that it will get work done. Definitely it will. But if it fails, then you need to have a mechanism in place that informs the origin that it failed. But maybe it's the point that maybe you can do the direct way than something, because transaction is like a term that really don't fly that well. It can have like many different aspects in place, yes. But
so basically you're not using distributed transactions. Okay, cool. So
no, we are not. No.
You're using some kind of confirmation message from the receiver in case of if you really need a guaranteed delivery there.
Yeah, those three things that I showed. Yeah, exactly. So yeah.
Okay, yeah, I forgot the first question, but the second one is you had this splitting up of the original message so that you have several queues.
Yeah.
But if you have basically two events and you need to, like in Decoupling, you need to watch them, that the first one ends and the second one ends, and then you fire the message, the result message, the handling.
So you want to basically read from two places and then write back to and do something else after.
I want to wait for several events to occur.
Yeah.
Fire something else. Is there like a type of this queue or?
Well, RabbitMQ offers many building blocks. Things I didn't even mention is that you can actually bind an exchange to a different exchange. So that opens up a lot of more possibilities. So you can do have a queue, and then you can basically put things into a different queue when there's nothing to be processed, and then when another queue gets something, then you can act. Like, there's many ways to kind of go about it. So you can actually subscribe to two queues, and then keep the message from one queue in an unacknowledged state until you get something in the other queue as well, and then act upon it.
Do you write tests for these components so that if you send a message, you check that the message was in correct format, and on the recipient side that they can accept and act on this message as well?
Not that much yet. We should be better at that. Yeah, you can definitely always be better at testing, but I mean, I would go about it in a way that I would test against writing the correct format that we have agreed to, but the term I think would be most useful in those situations is a contract-driven testing. If you haven't heard about it, then go out and read about it. It's really maybe a new thing, but basically it says that I will test whatever my consumers assume me to do. So it's more useful in actual direct interactions between services, but it can be used in message queues as well. So that I'm publishing whatever is being expected on the other side, And then if the other party who's consuming starts testing, it actually tests the other way around. Basically, you have to kind of learn about it. It's not my topic exactly, but context-driven testing will be one of the things that will maybe is the answer.
Sorry, it's a short one. You mentioned events. That something happens, then you publish an event. So basically, the event is something that also goes to some queue that somebody is consuming.
Well, it can go to a queue or can go to multiple queues based on bindings, depending on whether you want that message to arrive in a queue or not. It can go to nowhere, in a sense that you can have an exchange and just publish stuff there. And since you don't have any bindings, you just basically wipe them off on the disk and nothing happens.
Thank you. Great talk. Now we have,
Okay.